back in your salad days in Algebra 2, when you were first learning to graph rational functions, of which this is one, like you would have seen this, y equals x cubed minus 1 over x minus 1. And you would have known that x equals 1 cannot be part of the domain, right? And then you're trying to decide, hey, is this an asymptote? Is it something else? Is it a whole? Well, one of the ways that you could find out, and you probably did, this fraction means to divide. So let's try that. I'm going to do some synthetic division because it's the fastest, easiest way. And since I'm dividing by x minus 1, I'm going to put a 1 outside of the box. And this cubic polynomial that's up at the top, it is missing its quadratic and its linear term, so I need to put in 2 zeros here. So I've got 1, 0, 0, negative 1. Okay, synthetic division time. Let's see what you remember. I've got to bring down the 1, and then 1 times 1 gives me 1. Add these things together. 1, multiply them again. 1 times 1 is still 1. And 1 times 1 gives me a positive 1. Whoops, what happened with that one? I don't know. 1 times 1 gives me a positive 1. Add those things together, I get a 0, and that's the remainder, which gives me a quotient of x squared plus 1x plus 1. In other words, this function is equal to this. So y is equal to, I'm divided by x minus 1. So that is the first factor, and the second factor is this quadratic one, x squared plus x plus 1. And then our divisor is still down here. Okay. Now then, what we see here is that the top and the bottom have a common factor of x minus 1, so it can divide out, right? No matter what we stick in there, if I stick in a 3, this becomes 3 minus 1, it's a 2, and 3 minus 1 on the bottom, it's a 2, and they cancel out by division, right? It's equal to 1 for every single number except 1. It will always cancel out as long as it's not equal to 1. So whenever I simplify this, I get x squared plus x plus 1, which is the reason why this graph is a parabola, right? It's a parabola, and this function is identical to this one here everywhere, except at x is equal to 1. As a matter of fact, if you pull up a graphing calculator, which I will do, I'll use Desmos. Okay, and then we will type in our original function here. We'll type in y equals, if I can find the equal sign, put in some parentheses, x cubed minus 1, and then arrow out of this thing, division, and then x minus 1, I think. Right, and hit enter on that. There's that thing that looks like a parabola. It has a tiny little hole in it, but I can't see it because it's a speck, right? And then I graph that quadratic, y equals x squared plus x, and then I think it was plus 1. And you can see that blue one overlapping the red one, and I can turn it on and off, and you can see they're identical to each other. They're identical everywhere except for at the hole, because the red graph, boop, go off, has a hole in it, which you can't see, and the blue graph basically fills in that hole. So if I wanted to find that hole, all I would have to do is to go back to this function here and find, let's say I do it kind of in function notation, stick 1 in it. And I would get 1 squared plus 1 plus 1 is equal to 3, which was the value of the limit that we approximated with both the table and the graph, right? So this is the direction that we will head in the next lesson when we're trying to analytically derive the value of a limit.